Okay, we are going to continue chapter number 5, network layer, the control plane. So in last class we had discussed the SDN control plane through some examples, and today's class we are going to study ICMP protocol and then SNMP, and then we will start chapter number 6. So basically ICMP, it is called Internet Control Message Protocol. This protocol is basically used by host and routers to communicate network level information. For example, it is basically used for error reporting. And what could be the errors? The error could be that the host is unreachable, the network is unreachable, the port is unreachable, or the protocol is unreachable. Okay. So basically the ICMP protocol, it operates above the IP layer, and ICMP messages, they are carried directly in IP datagram. So it is above IP protocol. In ICMP message, ICMP, there are different types of messages, and these messages have type and code. So the type and code, the combination of type and code, the type value could be from 0, 3, 4, 8, 9, 10, 11, 12, and the code value could be 0, 1, 2, 3, 4, 5, 4, 6. Okay. So the combination of type and code, it shows that what is this message for. For example, if the type is 3 and the code is 0, so this ICMP message means the destination network is unreachable. So we will discuss how this message is generated. Okay. So basically, when in ICMP message it is type 3 and code is 0, so it means that it is destination network unreachable. So ICMP, it is a protocol that is used by host and the router mainly for error reporting. Okay, and the error could be that the destination host is unreachable, or the destination network is unreachable, or the destination port is unreachable, or the destination protocol is unreachable. So we will discuss about it. Okay. So let me explain how these ICMP messages are generated. So we are going to discuss it through some examples. Okay. First of all, you should come to know that, for example, we have this kind of network. Okay. Each host, it is running an echo server. What does echo server means? That when a message is received by echo server, the echo server accept the message and sends or retransmit the same message to the sending machine. So this is the functionality of echo server. Echo server means this is basically an application that is running on each and every host. And what does it do? When a message is received by echo server, the echo server accept the message and resend the same message to, again, that is bounce back the same message to the sending machine. So this is called echo. Okay. So suppose that we have a table here. Okay, and suppose that similarly each machine, it has a echo client. Okay. So the echo client, suppose this is sending a packet, so its type is 0 and code is 0. Type is 8 and code is 0. So this is an ICMP message. The source IP address is 223.1.21 and the destination IP address is 223.1.1.4. And this is ICMP message, so its type is suppose 8 and the code is 0. So this is the echo request. This is the echo request message. As you can see that the echo request message, which is normally called ping messages, so its type is 8 and code is 0. So therefore we generated this message. When this message is received by this router, so the router will look for, or it will search this packet, it will search the forwarding table, which whether the route is available. If the route is available, so which is the best route. Suppose this destination IP address is made with this first entry. Okay, so the packet is forwarded. Okay, so the packet is forwarded to this host, this router, suppose. Okay, and this router further forwards the packet to the destination. So when destination receives the message, so as we have explained to you that the echo server, it accepts the message and it sends the same message back to the sending machine. Okay, but the echo reply, so you can see that this message is received by the machine. Okay, so now this machine will reply back, it will send the same message. Okay, but the same data, but its type, its ICMP response message, its type will be 0 and code is 0. Okay, so this message will be sent to the sending machine again. Okay, so this is the ICMP echo message, and why it is used. It is used that whether a machine exists or not, whether a machine exists on the internet or not, whether it is responding or not. So normally you have been using ping utility. So this is the functionality of ping utility. The ping utility, it is using the ICMP echo request message and ICMP echo response message. Okay, so the ping utility, it is available whether on it is available on Windows and on the Linux as well. So we have discussed the two messages type, echo request and echo reply, the ping. Okay, so we have discussed it through an example. Okay, now we are going to discuss another example that is called destination network unreachable. Okay, destination network unreachable, what does it mean? As you know, suppose this is the host, sending machine, it generates a message. The source IP address is 223.1.1.2 and the destination IP address is this one. Okay, so suppose when this message is received here, okay, so suppose when the router receives this message, so router lookups in its forwarding table. Okay, suppose there is no destination. Okay, there is no destination. Okay, the destination network, it is because here the address is 223.1.10, so it is not matching with an entry, suppose. Okay, so this router, it will discard the message because this router doesn't know about this network, that is 223.1.10. This is the network number, suppose, and about this network number, for this network number there is no entry, so this network is unknown for this router. So the router will discard this message, and it will, but when the message is discarded, then this router will generate an ICMP message. This router, it will generate an ICMP message, and this ICMP message, its source address will be the IP address of this router. Suppose it is 223.1.9.1, and the destination address will be the sending machine, 223.1.2.1. Okay, and the ICMP message type will be 3 and code is 0. So type 3 and code 0 means the destination network unreachable. So it means that the message is not received to the destination network. Before reaching to the destination network, it reached to a router where the router doesn't know that where is this network, where is the network for this destination IP address. So this is unknown. A router, when it forwards the message, that router doesn't know, or that the forwarding table of that router doesn't have entry for the destination network, for the network of the destination IP address. So the router discards the message when the route is unknown, the network is unknown, but but the router will generate an ICMP message which is called destination network unreachable, and the source IP address will be the IP address of this router which discarded the packet, and the destination IP address will be the sending machine. So the source address, it will become the destination address, and the ICMP message type will be 3 and code will be 0. Okay, so this will be sent back to the sending machine. Okay, so we have discussed destination network unreachable. So destination network unreachable message, when it is received by any host, for example when this host receives the message, so it means that the message is discarded on its way. And why it was discarded? Because because the router, it doesn't know about the route toward that network. Okay, so now we are going to discuss another type of ICMP message, that is called destination host unreachable. Okay, so suppose again that this is the source machine, it generates a packet, a data packet. Its source IP address is 223.1.2.1 and destination IP address is 223.1.1.10. So the sending machine, it forwards that message to the router. When this router receives the message, so the router will look for the matching entry in its forwarding table. So you can see that this destination IP address is 223.1.1.10. So this IP address is matching with this entry 223.1.1. So the message will be forwarded to on this link. Okay, so you can see that this message is forwarded on this link. Okay, so when this router receives the message, suppose it also forward from here to here, because the destination network 223.1.1 it is available here. Okay, but you can see that when this router forwards it, so you can see that this router, it will see that there are hosts. So this 223.1.1, this is the network part. Okay, the destination IP address is 223.1.1.10. So the message is first forwarded to the network by using the network part 223.1.1. This network part of the IP address, destination IP address, it is used to forward the message to this network. So when the message is reached to this network, then the host part is examined. The host part is 10. So whether there is a machine with the host part 10, no, there are machine with it is 223.1.1. This is the host part 1. 223.1.2, this is the host part, and 223.1.4. So 223.1.10 machine is not available. So it means that the network address, it was correct. The network address was correct. So the message has reached to the network. The previous message, it was discarded. Why? Because a router doesn't know about the route, but here the router knows the route. Okay, the message is reached to the network. But here in the network, there are 3 hosts with the IP address .1, .2, .4. The host with the IP address .10, it is not available here. So the message will be discarded because there is no destination. So here, in this case, the message has reached to the destination network. But in the destination network, the destination host, in this case, it is 10, it is not available here. So the message will be discarded by this router. Okay. However, when this message is discarded, then this router, it will generate an ICMP message. It will generate an ICMP message with the source IP address, this one of this router, and destination IP address will be the source, and the source in this case is 223.1.2.1, and the ICMP message type will be 3 and code will be 1. So this means destination host is unreachable. Okay. So you can see that this message will be forwarded to the source. So when the source receives this message, so it means that the network number is correct. The message has reached to the network. Okay, but the host is not available there. Okay, so basically this ICMP message, it is used to localize the error. Okay, to localize means to show that why this packet was discarded here. So when the router discard a packet, so the router generate an ICMP message that why this message was discarded. This message was discarded because there was no destination host with the IP address 223.1.10. So the message was reached to the destination network with the address 223.1.1, but the host part .10 it is not available here. So that's why the router discarded the message. Okay. So but in the previous case, the packet doesn't reach to the, even to the destination network. The packet was discarded by a router which didn't have the path. Okay. So basically the ICMP message it is used to localize the fault. Localize fault means to show to the destination to the source or to the sending machine that why his or her message was discarded. Okay. So this is the type and code for the destination host unreachable. Okay. So we discuss it. Similarly, we are going to discuss another example, that is destination protocol unreachable. Okay. Again, suppose that this is a source machine. Okay. This source machine it generated a message. Source IP address is 223.1.2.1. This host. Destination IP address is 223.1.4. This machine. The protocol at the transport layer it is UDP, and this is the data packet. Okay. So this machine it will forwards the packet to the router. So when router receives this message, so it will look for in its forwarding table. Okay. Suppose the packet is matching with this entry, so the packet will be forwarded on this link. Okay. So you can see that. Now when this router it receives the message, okay, so it will see that the destination address is 223.1.4. So the message will be delivered to this host, this machine. Okay, so it means that the message has reached to the destination host. Okay, in the previous case the message was not reached to the destination host, but here the message is reached to the destination host. So when the message is reached to destination host, so it passes through the physical layer, then data link layer, then network layer. Okay, and when message comes to the network layer, then the network layer decides that what is the destination protocol. The destination protocol is UDP. So the network layer it will give to the transport layer. Which transport layer? UDP. But here the transport layer protocol is TCP. The UDP protocol at the transport layer is not available. Okay, you can see that the destination protocol is UDP, but here the network layer, when it delivers the message to the transport layer, the transport layer has only TCP protocol. UDP protocol is not available. So this destination host it will discard this message here. And why this message was discarded? Because the packet it is for the UDP protocol of a transport layer, but at this machine the transport layer is only TCP is available. The UDP protocol is not available. So if the UDP protocol is not available, so the message will be discarded. Okay, now the message is discarded, so this machine has to send the error that why this message is discarded. Okay, so this machine it will generate an ICMP message which is called destination protocol unreachable. Okay, and the source IP address will be the machine of this machine, because here the message is discarded. So this will be the source address, and the destination machine will be the sending machine. Okay, 223.1.2, and the ICMP type will be 3 and code will be 2. So type 3 and code 2 means that the destination protocol is unreachable. Okay, so this message will be sent to the sending machine. So when this machine receives this message, so it means the sending machine it will come to know that the packet is forwarded to the destination network. It is the router, they had the route in their forwarding table, and their router they forwarded the packet to the destination network. And when the packet is reached to the destination network, the destination host was also available. So the message is received by destination host. But in the destination host, when the message was given to the transport layer, so the transport layer, the packet had the protocol UDP. But here at the transport layer, TCP is available, UDP is not available. So the message was discarded. Okay. So it means that the destination network is reachable, the host is also reachable, but on the destination host, the protocol is not available. Okay. So you can see that this upper layer protocol, it is basically used by the network layer to identify that this message is whether for TCP or it is for UDP. Okay. Now, so we have now also discussed the message type 3 and code 2 that is used for destination protocol unreachable. So I think you should know about the destination protocol unreachable, what does it mean, and destination host unreachable, what does it mean, and destination network unreachable, what does it mean. Okay. Now we are going to discuss another example, another scenario, which is called ICMP destination protocol unreachable. What does it mean? Suppose this source, this is the machine, it generates a message with the source IP address 223.1.2.1. The destination IP address is 223.1.1.4. So this machine is sending data to this machine. Okay, and the destination port number is 88. The destination port number is 88, and the protocol is UDP. Okay. So when this message is received by the router, so the router, it will look for the matching entry in its forwarding table. Okay. So the destination network number, it is matching with this entry. So the packet will be forwarded on this link. Okay. So when this router, it receives the message, okay, it will look up in this forwarding table and it will find that the destination IP address 223.1.4, it is exist here. So the message will be forwarded to this this machine. Okay. So now the message is received at this machine. Now at the network layer, the destination, the network layer at the destination protocol is UDP. So the network layer, it will give this message to the UDP. The UDP protocol is available here. Okay. So the message will be given to the UDP. But you can see that when the message is given to the UDP will see the destination port number. The destination port number is 88. So based on the port number, the destination can identify the UDP key that this message is for which application. And suppose the port number 88 for UDP protocol, it is closed here. It is not running. It is closed. It is not available. It is not available here. The port number 88 with the port number 88, it is not available here. It is closed here for the UDP protocol. So the UDP, it will discard this message because the destination port number 88 is not available here. So if the port number 88 is not available here, the message will be discarded. So when the message is discarded, then the ICMP will be invoked, because the ICMP has to send the cause that why the message was discarded. So the message is why discarded. So this machine, it will send the ICMP message. Okay. So the ICMP message, it will be sent, and the ICMP message, its type will be 3 and code will be 3. And who discarded? This machine. So this will be the source IP address, and this is the sending machine. So the destination IP address will be this. So when this message is received by the sending machine, so the sending machine comes to know that the message is forwarded correctly to the destination network, and the message is also delivered to the destination host, and the message is also delivered to the destination protocol, but the port number is closed there. So that's why the message is discarded. Okay. So similarly, we have this is the destination port unreachable. Okay. Similarly, we have another type of message which is called ICMP TTL. Okay, we are going to discuss the ICMP TTL expired message. What does it mean? Okay. So suppose again that this is the destination, this is the sending machine, it generates a message with the source IP address 223.1.2.1 and the destination IP address is 223.1.4. So this message is from this machine to this machine. The destination port number is 88 and the TTL is 2. TTL means time to diff. Okay, this is the integer value. Okay. So when this message is received by the router will look for the matching entry in the forwarding table. Okay, so you can see that this packet it match with this entry, so the message will be forwarded on this link. Okay, but before forwarding the message, we know that the TTL will be decremented. Okay, the TTL value will be decremented. That is, the TTL will be now it is 1, it is 2. Okay, the TTL value is 2. So before forwarding it, the TTL value will be decremented, and the TTL value becomes 1 because it is 2, so it will become 1. So before forwarding, the TTL value is decremented, and then the router will examine if the TTL value is greater than 0, then the packet is forwarded. If it is less than 0, then the packet is discarded. We know that the TTL is used to discard the packet, okay, so that the packet doesn't move far over in the internet. Okay, so it basically is used for this purpose. So we have discussed this TTL value in detail in the IP header. Okay, so now since when this router it finds the matching entry that this packet it should be forwarded on this link, so before forwarding, the TTL value will be decremented, and then it will examine that whether the TTL value is greater than 0 or not. If it is greater than 0, then the packet is forwarded. So in this case it is greater than 0, so the packet will be forwarded. Now the packet is received by this router. When this router receives the packet, so it knows that the destination is available here, so it will forward on this. But before forwarding, it will decrement the TTL value. It will decrement the TTL. So you know that before forwarding, it will decrement the TTL value, and the TTL value it becomes 0. So the TTL value is 0, so the packet will not be forwarded. The packet will be discarded here. So when the packet is discarded, then the ICMP is invoked. Why? Because the ICMP will sense the error message that why this packet is discarded. So here the packet is discarded because the TTL value is expired. The TTL value is expired. Okay. So this is the ICMP TTL expired message. So its source IP address will be the IP address of this machine where the message is discarded, and the destination IP address will be the sending machine. And the ICMP type is 11 and code is 0. Okay. So this message will be sent to the sending machine. Okay, so you can see that the traceroute, we have also examined the traceroute message. Okay, this utility we have discussed this utility in the chapter number 1. Okay, so this traceroute, this application, it is basically developed based on ICMP messages. Okay, this traceroute is used. The traceroute application, it basically let us know that from source to destination how many routers are there. That is, when the message moves from source to destination, then the message is passed through which routers. Okay, so how to determine the number of routers from source to destination and a path? So basically we use the traceroute application. And the traceroute application, how it works, basically the sending machine, it generates the message with the TTL is equal to 1. So TTL equal to 1 means that when this message is sent from here to here, okay, when the message is received here, the message will be discarded. Why? Because when the message is sent from here to here, then it will forward it, but before forwarding, the TTL value will be decremented. So the TTL is 1, so it will become 0. So when the TTL becomes 0, then the message will be discarded. And when the message is discarded anywhere, the ICMP is invoked. The ICMP is invoked, so ICMP message will be sent that the TTL is expired. So here, when the ICMP message is sent, so here this will be the source address. So it comes to know that this is the first router. Okay. After this, the source machine it sends another message, the second message, but the second message the TTL value is equal to 2. Okay, so the message is sent from here to here. When the message is received here, then this router will forward it, but before forwarding, the TTL will be decremented. so the TTL is equal to 2, so it will become 1. So the message is forwarded to here. When this router forwards the message, so before forwarding, the TTL value will be decremented. So now the TTL is 2 or is 1, so it will become 0. So when it becomes 0, the message will be discarded. So when the message is discarded, the SNMP message, the ICMP is invoked. The ICMP message will be sent. But in this case, when the ICMP message is sent, this will be the source address. Okay, so the sending machine come to know that this is the first router, this is the second router. Similarly, the source machine, it will send the third packet with the TTL is equal to 3. So when the message is sent with the TTL equal to 3, then this message will be discarded here. So when this message is discarded here, the third message is discarded here, so it will generate ICMP message. And when this generates the ICMP message, so the source address will be of this router. Okay, so the sending machine comes to know about the third router. Similarly, for the fourth message, for the fifth message, okay, until the destination. Okay, so this is basically used. Okay, so when datagram in ninth set of router it arrives, for example, it arrives at the first machine, then and the TTL gets to 0, then the message will be discarded. Okay, so the router discards the datagram and sends the ICMP type 11 and code 0. This means that the message is discarded at this router. Why? The TTL is expired. Okay, so similarly, when the TTL is equal to 2, and similarly for TTL is equal to 3, and so on. Okay, so now we have discussed the ICMP. So this ICMP message, it is basically used that what is the fault in the network, why the packet is discarded, why the packet is discarded in the internet. So this, by using the ICMP message type and code, we can now know that why the message is discarded, what is the error. Okay, so similarly we have the ICMP message with the type 3 and code 6. This means that the destination network is unknown. One is the destination network is known, but it is unreachable, there is no route. And one is that it is unknown, it is unknown network number. Similarly, the destination host is unknown. And this source quench, it is basically used by congestion, it is not normally used. So it is when a packet reaches to a router and the router buffer is full, so the message will be discarded. Okay, similarly we have the messages type 9 and code 0. It is used for route advertisement, and similarly for router discovery, and similarly it is the message when the IP address is the IP header is bad, that is the IP header is wrong. Okay, so we have discussed these ICMP messages. Now we are going to discuss network management. Okay, what is network management? Basically, in a computer network, we have hardware as well as software. Okay, and we have different protocols, like for example HTTP, DNS, etc. Okay, so basically the computer network, it is very complex. Okay, so when this network is deployed, okay, so what does network management mean? That the network is deployed, that the hardware, the router, host, they are deployed, they are interconnected. Integration means they are interconnected. The hardware, the machines, they are linked with each other, and the protocol, they are installed, the protocol, they are configured. Then after this, the network start running. Then the network should be monitored, that whether the network is working properly or not, whether there is an error or not, there is a loop or not, whether a link fails or not, a router fails or not. So we have to monitor. Why? We have to monitor that whether the network is working properly or not. Sometimes we have to test. For example, we deployed the network, we configured the protocol, then we have to test that whether they are working properly or not, the net is available or not. Sometimes we have to pull, we have to go to a router and we have to check its configuration. Similarly, we have to configure, analyze and evaluate and control the network elements to meet the real-time operational performance and quality of service. So we have to monitor the network, that either the computer network or internet, it is working as per requirements or not. Okay, so a computer network, it is complex system. Like for example, if we have a complex system like airplane, nuclear plant, so before it start working, we have to test that whether it will work finally, it will work correctly or not. And when it is tested and when it start running, then still we have to monitor it, that whether it is working properly or not, whether there is a fault or not fault. Okay, so basically I would like to explain that what does network management means. So the network management, it first involves deployment. Deployment means that you connect the routers, host, etc., and you connect them through the links. This is called deployed. After this, we configure the network. What does it mean? That we configure the routing protocols at the routers. We assign the IP addresses to the machines. We assign the network number, network mask, etc., and so on. We use ACL policies. For example, we have to configure ACL policy that whether the students are not allowed to access Facebook, the student cannot access exam or account offices. Similarly, we have to install and configure net. We have to install DCP, which is the public IP address, which is the private IP address, etc. So all these things, they are done. This is called configuration. So when this configuration is done, then we test that whether it is correct or not. For example, if the message can be sent from here to here or not. Okay. So when they are tested and they are correct, then we start its running. Okay, now the internet is running. So when the internet start running, okay, so still we have to monitor it. We have to monitor. Why we have to monitor? We have to detect the fault. Okay, so what could be the fault? The fault could be logical or the fault could be physical. Physical means that this router gets failed. Okay, this link is disconnected. It is basically broken, suppose. This is physical fault. And one is logical fault. For example, we discuss count to infinity. There is a loop. Okay, the message is sent from here to here, but the message goes from here to this router from to this, and this to this. So the message is circulating between these three routers, and the message doesn't reach to the destination. So this is called loop. So this is logical fault. So we have to monitor the network when it starts running for fault. And fault, what does fault management means? That whenever the fault is occurred, so we have to detect it. So this is the least requirement. The least requirement is that whenever the fault is occurred, it should be immediately detected. And it will be a little bit better if you could localize it. Localize means that if we can tell that what is the problem, what is the where the fault occurs. For example, you can see from ICMP messages. Okay. For example, if we receives this message, if this sending machine, it receives the TTL is equal to 0. So it means, so through this ICMP message, it comes to know that the packet is discarded because the TTL value was less. So what should it do? So it should increase the TTL value. If the TTL value becomes 4, then the message will be forwarded from at the router. The TTL will become 3. When the message reached here, it will be forwarded. The TTL will become 2, so it will be reached here safely. Okay. So by learning, if the fault is detected, that the packet is discarded, and why it is discarded, so through the type and code, we can detect that TTL value is 0. From this type and code, we can come to know that the TTL value is the message is discarded because the TTL value was expired. So the message was discarded. Why? The TTL value expired. So so it should resend the message, but with the increased value of TTL. Okay. So this is called localization. That we should, when the fault is detected, that the message is discarded. Why it is discarded? The reason. This is called localization. And the third thing is recovery. That we should recover automatically. Okay. This is called fault management. Okay. So the network fault, it should be first detected, and if it detected, then it should be localized. Localized means that why this fault occurred. And third is that we should recover it. We should recover it. But another algorithm that is very good, if we can predict the error, that why this error has occurred. Okay, that why this error has occurred. Okay, prediction means that before the error occurs, so we have to predict it, that this error occurs. So before its occurrence, we should take the precautionary measures. Okay. So it is basically a very wide, it is basically a broad area. Okay, now we are going to discuss a protocol that is called SNMP, that is used for network management. Okay, so first in this network management, we have some devices that we want to monitor. Okay, these are called managed devices. For example, host, routers, switches, etc., or server. So these are called managed devices. These devices should be managed. Okay, that we are going to monitor these devices for fault. Okay, so the managed devices, they contains managed objects. So in this device, so what is to be monitored? For example, the LAN card, the operating system, etc. Okay, so in this router, whether the port, the link, or the router itself should be monitored. Okay, so basically the managed devices, it is represented through managed object. Okay, and the managed object, it sends the data. It sends the data where? To a server. Okay, we will discuss it. Okay, so there is basically a server which is called managing entity. Okay, and this managing entity, it contains a database which is called management information base. Okay, and in each managed device, okay, in managed device we have managed object, that in this device we what components we are going to monitor. For example, the protocols, ARP, IP, etc., whatsoever. So these are called managed objects. So in each managed device we have an agent. For each managed object, it creates a data. For example, after every 2 seconds, okay, this devices, it checks its LAN card, that whether the LAN card is running or not, it is power off or powered on or powered off. Okay, so this data is sent to the server. This is called managed entity, and this managed entity, it contains the information in the management information base. So you can see that in each managed device we run the agent, and these agents, they monitor the managed devices, and they sends the data to the managing entity, the server. So here the server, so sometimes the messages are periodic. Periodic means that after each 5 seconds this device sends to the managing entity that the LAN card is running, the card is running. So suppose when the card stop running, so then this device will send immediately the message. Okay, so you can see that these are the managed devices, and this is the managed entity, this is the server. This is managing all these managed devices. So these managed devices, they have agents. They sense the data of the managed devices in the managed objects. Okay, in the managed objects they send the data, and this data is stored here in the managed information base. So the managed entity and the managed data, managing entity, the managing server, and the managed device, they talk to each other by using a protocol. So for this purpose we are going to discuss a network management protocol, and for this purpose we are going to discuss the SNMP protocol. Okay, so SNMP is one of the protocol that is used by managing entity and the managed devices to communicate with each other. Okay, so in SNMP there are 2 ways to convey MAB information commands. So as I have told you that each managed device, they sends the data by using managed objects to the server, and this server, it stored the data in the management information base. So this has the managed information base. So this management information, the data from all agents or managed devices, they are stored here in the managing entity, and this how the data is stored. The data is stored in management information base. So there are 2 ways to convey the information from managed devices to managing device. One is called request and response. What does it mean? That this server, it requests to these managed devices that send me your data for this link, for example, that whether this link is running or not. Okay, so this devices, it is sending request to the managed devices to send the data of this link. Okay, so when this request is received by the managed devices, then it responds with the response. It sends the response message. In the response message, it first get the information of this link. Okay, this link is running, so it sends the message that the link is running. If the link is not running, it will send the response that the link is not running. Okay, so this is called request and response mode. Okay, so when this server, it sends the request message that send me the information about your managed device, so it sends the response message. Another is called trap mode. Trap mode means that when this link is failed, then this device will immediately send the data. This is called trap mode. Okay, so this server, it doesn't solicit the message, but it is when this link is failed, then the message is sent immediately. This is called trap mode. Okay, so as I have discussed that the managing device and the managing entity, that is the server and the managed devices, they talk to each other using the protocol. So we are discussing SNMP protocol. Okay, so okay, this is one of the protocol that is used by managed device and managing entity. Okay, so this in this SNMP messages, there are different types of messages. Okay, this is called get request, get next request, and get next bulk request. So these are the messages that are sent from the manager, from the managing entity, from the server to the managed device, to the agent. And this, it is request. Request means that the server is requesting to the managed device to send me the information about the managed device. Okay, so this, it can be a get request net, and get bulk. These three type messages, they are used for request. But here in this we have only single request, but here we have more than one request, and here we have a lot of requests. Okay, and one is the inform request. Basically this is sent from one server to another server. Okay, this is sent from one server to another server. For example, we have here a managing entity, and we are a managing entity. So these managing entity, these server, they talk to each other. So when they send the message to each other, so this is called for this purpose they use the inform request message. And one is called set request message. What is it means? So when the managing entity wants to set the value, to configure the value here of this router, for example, this link is failed. Okay, so this entity sends the message that to power on again, so that this link is on. Okay, so this is called the set messages. Okay, so the set request, these are the messages that are sent from the manager to the agent, such that the particular configuration value is set. And the response we have discussed with the this is the message that is sent from the managed device to the managing entity. When the managed device, it receives a request message. Okay, and the trap, it is basically sent from the managed devices to the managing entity when a particular event happens. Okay, when a particular event happens. Okay, so this is actually, these messages, they are sent using the SNMP protocol. So this they have header like this one. Okay, so it has PDU type, request ID, error status, and so on. Okay, so this error status means when the message is received by a managed entity, for example. Okay, so whether that message is successful or not. Okay, error index, and so on. Okay, so we have discussed so the chapter number 5, it is finished. Okay, in the chapter number 5 we discussed per router control plane, we discussed routing protocols, link state, distributor, etc. We discussed logically centralized control plain software defined networks. We discuss SDN controller. We discuss ICMP message, which is used for the error reporting. Okay, and we also discuss network management and network board. Okay, so this is so the chapter number 5 is finished. Then we will start chapter number 6.